Humanity has made some objects travel at nearly the speed of light.
The Large Hadron Collider, the biggest machine for breaking tiny bits called particles, is starting up again today. It had a 3-year break for improvements. The machine was a long tunnel full of parts that sent energy beams around a big circle. Walking this circle would take about 6 hours. One of the most exciting things that they do at CERN is smashing particles together. They use a lot of energy in this work to learn secrets about the universe. The Large Hadron Collider at CERN is the strongest machine ever made for making particles go very, very fast. But how fast? Imagine countless tiny particles, no bigger than a dot. We're talking about trillions of them, like grains of sand on a beach. They're called protons, and they're gearing up for the ride of their life. Picture a racetrack, but this isn't any normal race. This is the LHC, the world's largest and most powerful particle accelerator. It's a huge ring, bigger than any football stadium. Now imagine those trillions of protons zooming around this huge ring. They're not going just fast, they're going nearly as fast as anything can go in the entire universe. They're racing at a speed so close to the speed of light. It's like comparing the speed of a snail to a bullet. And they didn't do it just once, they do it over 11,000 times in a single second. Blink and they would have gone around more than 40,000 times. This incredible dance of tiny particles is what's happening inside the LHC. A testament to human curiosity and capability and the thirst for knowledge. It pushes very small bits like protons or ions to almost the speed of light around a circle that's around 17 miles long. The circle is made of very strong magnets. The machine is about 328 feet below the ground. These magnets and other structures help the particles gain more energy as they go round and round and round the circle. Superconducting magnets are chilled to temperatures colder than outer space, allowing them to conduct electricity without any energy loss. These magnets are cooled using a system that circulates cold liquid to maintain their low temperatures. And these strong machines might lead to new ideas, like other dimensions. This idea, which used to be only in science fiction books, is now a big part of physics. It makes us wonder about the amazing things that might just be out there. One of the most popular theories, string theory, says that our universe is not just made of 3 dimensions, but it has 10 or 11 dimensions. It tells us that the basic parts of the universe are not just tiny particles, but really small, shaking strings. These strings shake in many dimensions, and the different ways that they shake create many particles we see. This exciting theory solves some of the disagreements between 2 major physics theories, quantum mechanics and general relativity, by suggesting that these have extra dimensions. Then we have M theory, which is a bigger version of string theory. It suggests that if there are 11 dimensions, it also says that our universe is one amongst many, floating like a thin sheet or brain in an 11-dimensional space. These universes could interact with each other, creating effects that we see as dark matter and dark energy. Now let's look at the many worlds theory of quantum mechanics. This theory doesn't exactly suggest extra space dimensions, but, it imagines an endless number of parallel universes, each representing a different result of quantum events. It's as if the universe is always splitting into many copies of itself at every moment, each following a different path of history and time. Interestingly, even though these theories might seem like they're just guessing, they're actually based on serious math, serious physics. They offer possible answers to some really tough questions in cosmology, like what dark matter and dark energy are, how quantum mechanics and general relativity can agree, and the mystery of the Big Bang. But the hard part is finding real proof for these theories, the problem that continues to push science and technology forward. The idea of other dimensions is a really interesting mystery that continues to excite scientists and regular peeps alike. Whether they exist as shaking strings in higher dimensional spaces, as parallel universes splitting off at every quantum decision, or as brains floating in an 11-dimensional space. New dimensions introduce a universe, or should we say a multiverse, of exciting possibilities. The search to find these dimensions is not just a scientific project, it's a journey into the very core of reality and our understanding of the universe. Some theories, like string theory, suggest that there might be more than the 3 dimensions that we're used to in the universe. If extra dimensions exist, they would be very tightly packed or twisted into small scales that we just can't really see right now. However, the strong crashes made of the LHC might open up these hidden dimensions for a very short time, giving us a peek at their existence. But there's more. There are things called Kaluza-Klein modes, which are possible particles that could appear because of extra dimensions. These unknown particles could be the result of extra energy made when particles smash together at high speeds, leaving marks that CERN detectors can see. Also, if there are any extra dimensions, they would change the way known particles behave in very surprising ways. So in this situation, particles might take paths that go into these hidden dimensions, leading to a weird thing, energy or movement disappearing in experiments. Particles seem to break the rules of energy and movement in our 3-dimensional world and escape into dimensions beyond our understanding. Imagine standing on the edge of a wide, unknown field. This isn't a normal field, though. It's a space where everything we know about the world stretches and changes. It's this is where scientists work to understand the big questions about how our universe works. One of these questions is about whether extra dimensions might be hidden from our view. Scientists think that they might find answers in the strange behavior of tiny things called particles. When particles break down or decay, they can lose some energy or momentum. This energy or momentum doesn't just vanish, it has to go somewhere, but where? Scientists think it might be going into these extra dimensions. By studying this decay process slowly, they look for clues that might suggest these extra dimensions really do exist. CERN is a key player in this search. When scientists smash particles together at very high speeds, that causes a lot of energy to be released. Some of this energy doesn't behave as scientists expect it to. This could mean that there are extra dimensions that we can't yet see. But so far, these extra dimensions remain hidden. We have yet to find solid proof that they actually exist. Still, these strange findings do give scientists hope. They dream of one day being able to travel these to other dimensions. Just think about that. It sounds like something from a science fiction story, right? Well, now let's talk about something called quantum entanglement. That's where a particle, no matter how far apart, seems to be linked to another particle. They can influence each other instantly, even if they're on opposite sides of the universe. It's as if they're connected by a secret, hidden force. It doesn't care about distance or time. That goes against our normal understanding of cause and effect. It suggests that information could travel faster than light. To investigate this further, CERN scientists are pushing the boundaries of our knowledge. They're asking, could quantum entanglement tell us more about these hidden dimensions? They make particles become entangled in the lab, and then they separate them over large distances. They then study how these particles behave. They hope that this will tell them more about the hidden dimensions that they're searching for. As Albert Einstein once said, a terrifying action at a distance. Despite their hard work, scientists have not yet been able to open a door to another dimension. But their experiments have given us important clues about how the universe might work and the possible existence of other dimensions. During its search for knowledge, the LHC has found some weird stuff. One of these is that particles smash into each other more often at certain energy levels than they should. That doesn't fit with what we normally expect from particle physics. It's like the particles are playing by a different set of rules here. And there's more. In special experiments, known as beauty experiments, scientists study a type of particle called a beauty quark. When this particle breaks down, it doesn't behave as scientists expect it to. It's as if a hidden force is guiding these particles. This suggests that we need to think beyond what we currently understand. And there's so much more to explore, including one truly fascinating discovery. Something incredible has happened with tiny particles called neutrinos, which are usually very difficult to detect. They've been clearly observed at a massive science center called the Large Hadron Collider. Whoa, we were just talking about that. Wild. In a special experiment called the Opera Oscillation Project, scientists found something that really surprised them. They saw that neutrinos seem to be moving even faster than light. This finding is very important because it seems to go against what Einstein explained in his theory of relativity. This theory, which has been a key part of how we understand the world of physics, says that nothing can move faster than light. So this new discovery has got everybody's attention because it might make us rethink some of the basic ideas that we have about how the universe works. It's a reminder that there are very few certainties in this world, and we like to think that we have a lot of them, but truly, have you thought about the Higgs boson particles? They're really interesting because they help us know where mass comes from. Lately, people have been talking a lot about them because they seem to be heavier than we first thought.
To understand the Higgs boson, I think of a Hollywood party.
Some scientists are wondering if this could mean that these particles are somehow linked with other particles in spaces and dimensions that we can't usually see or measure. It's like a twist in our search to understand the basics of the universe. So are we getting a peek at these hidden dimensions? Well, then there's gravity. It's a force that keeps us anchored to Earth. While we're used to gravity, it's a big mystery to scientists. The LHC's intense experiments have opened up ideas about extra dimensions that might explain why gravity is so weak compared to the other fundamental forces. All of these exciting findings don't necessarily prove that other dimensions exist, but they do challenge what we thought we knew about the universe. They raise questions that we can't answer using the standard model of physics. These experiments' strange behaviors and unexplained results are like a call to adventure, urging us to take a step into the unknown. Fun song. The LHC, a giant particle smasher at CERN, might have unknowingly unlocked a door into a whole new world. Oh my god. A whole new world? That's gotta be a coincidence. Anyways, a whole new world that can help us understand the cosmos. As scientists learn more about the Higgs boson, they start to see connections that could point to extra dimensions. The Higgs boson could be a doorway into unforeseen worlds. So how does it work? Well, the Higgs boson's properties and the way that it interacts with other particles are key. Some theories suggest that these extra dimensions could affect the Higgs boson. If you're wondering how we could find these hidden dimensions, here's the plan. So, scientists are closely studying how the Higgs boson behaves. They're looking for things that don't really match up with what we'd expect. One thing they're focusing on is the mass of the Higgs boson. Particles in these extra dimensions might affect the mass of the Higgs boson. By measuring the mass of the Higgs boson and comparing it to what our theories predict, we might be able to unlock the secrets of the universe. Yeah, that's a big one. But the Higgs boson isn't just studied by observing it directly. At CERN, scientists create extreme conditions by smashing particles together. They then study how these conditions affect the Higgs boson. These high-energy collisions could allow us to explore these extra dimensions and understand how they impact the properties of the Higgs boson. Micro black holes, or teensy-tiny black holes, are an interesting subject that has drawn the attention of many scientists. Think of them as pocket-sized versions of the black holes that we often hear about. They could shake up our understanding of the universe. These teensy-tiny black holes are predicted by complex theories like string theory. They could possibly be made using the energies found at the Large Hadron Collider, or, the LHC. Now, that might sound crazy, but any black hole smaller than Planck length, a very, very small distance, would disappear quickly due to something called Hawking radiation. Finding these tiny black holes would be like finding a needle in the haystack, but it would prove that they exist. But here's where things get a little bit heated. Some people worry about the creation of these micro black holes. They feel that these tiny black holes could grow into monsters that could swallow the Earth. But don't worry, those who support the study of these tiny black holes said that they don't need to worry. They believe that Hawking radiation would prevent the black holes from getting too big and causing a disaster. Studying micro black holes is interesting because it could give us a new way to understand gravity and space-time. By understanding these amazing objects, scientists hope to learn more about how they work. Looking at the birth and death of these tiny black holes could be like a lab experiment for understanding how extra dimensions affect gravity. By looking at the leftovers from the evaporation of these black holes, scientists could learn about the structure of extra dimensions. The detectors at CERN might even spot unique signs for the creation of these micro black holes. These signs would show energy and momentum patterns that don't fit with a standard model of physics. Scientists hope by looking at these signs they can find evidence of extra dimensions and the creation of teensy-tiny black holes. Okay, I won't say that ever again. I'm so sorry. I don't know what I was thinking. Micro black hole research at CERN is a promising and exciting field, but we still haven't found any solid proof that they're doorways to other realities. However, the effort and determination shown by the scientists in searching for answers is truly inspiring. I mean, they work tirelessly to grow our understanding and solve the mysteries of the universe. We really should commend them for their hard work. As we continue to learn about these tiny black holes through experiments and theories, we might just open up a door to a new universe. But here's something to consider. In particle physics, we base our understanding on rules like energy and momentum conservation. But what if these rules weren't as set in stone as we thought? Yeah, in the Large Hadron Collider, something amazing happens when particles crash into each other at high speeds and energy. We have to make sure that energy and momentum are conserved or balanced out. However, some experimental results and theories suggest a different story, that hints at the existence of hidden dimensions. Some of the particles in a collision can escape into these hidden dimensions, and when they do, they take energy and momentum with them. That leaves a puzzling gap, a missing piece in the puzzle of energy and momentum that we can't explain using our current rules. Researchers at CERN are like detectives. They carefully go through the details from high-speed particle collisions. Sometimes they notice something strange. Energy and momentum seem to disappear. This can't be explained by the particles that we know today, making us wonder if there might be unknown dimensions where this energy and momentum have gone. These curious finds are then carefully examined by scientists. It's a big surprise to think that energy and momentum might not be conserved as we'd expect, but we need to be cautious. We have to think about all the possibilities, like particles that haven't been found yet or mistakes that might have happened. Then another idea comes into play: supersymmetry. This is an interesting idea in particle physics that suggests that there is a perfect balance, a symmetry between two types of matter particles, fermions and bosons. This theory suggests that each particle we know has a superpartner with opposite properties. These superpartners might fill the gaps in our understanding of the universe. Supersymmetry doesn't stop at matching up particles, though. It helps answer some big questions about energy levels in the universe, which we call the hierarchy problem. One way it does this is by suggesting that gravity in higher dimensions might cancel out quantum corrections to the mass of the Higgs boson, a particle that gives other particles mass. This connection provides a natural explanation for the observed masses of particles. Additionally, the superpartners predicted by supersymmetry have similar properties that might give us a way to see these unseen dimensions. Despite years of hard work, scientists have not yet found solid evidence for supersymmetry or its connection to extra dimensions. This lack of experimental proof raises doubts about the theories that rely on supersymmetry. However, scientists remain hopeful and determined to explore supersymmetry further because it has the potential to provide answers to significant mysteries in particle physics. To investigate the existence of unknown dimensions, researchers are looking into a concept called gravity's rainbow. Gravity's rainbow is a theoretical idea that aims to combine two important theories in physics: quantum mechanics and general relativity. It suggests that the behavior of particles and fields might be influenced by the energy they possess in higher dimensions. Now, if that's true, It could change our understanding of how gravity works and challenge Einstein's theory of general relativity. By studying gravity's rainbow, scientists hope to unravel the secrets of our universe and gain insight into these unexplored dimensions. It'd be a game-changing discovery if we could detect these subtle changes in how gravity works. It would provide strong proof of the existence of extra dimensions, which have remained hidden until now. This exciting journey into the unknown could completely change our view of the universe. Gravity's rainbow predicts that gravity's strength at very short distances could be changed by extra dimensions. This could lead to particles behaving differently from how they would under traditional laws of gravity. Scientists can explore this possibility by studying how particles interact gravitationally at very short distances. Black holes, which are so strong that not even light can escape, provide a unique opportunity to investigate the potential existence of extra dimensions. The properties of black holes, such as how they form, their stability, and even how they might disappear, could change in the presence of extra dimensions. By watching these cosmic mysteries and comparing their behavior to theoretical predictions, scientists might be able to detect signs of other dimensions. As we delve into the secrets of the Large Hadron or Hadron Collider at CERN, we're forced to ask big questions about the universe. What are the mysteries hidden within the tunnel? What amazing discoveries have scientists made? Are we about to solve the mystery of parallel universes? In the world of today, we have made massive strides in artificial intelligence, and now we're venturing into the realm of extra dimensions. You know, science fiction existed because it's our imagination of what the future could look like. And it's absolutely mind-boggling that, in a lot of ways, feels like science fiction's becoming real. Like our predictions had some weight to them. But anyways, what are your thoughts? Let us know in the comment section down below. Hit that like button and subscribe for more.